Hello everybody and welcome back to Absolute Value. Happy summer, and we're going to keep going with our math to keep you on track for the next school year. Today we're going to focus on geometry, and we're going to talk about one of the most critical bridge topics for geometry. In Algebra 1, we often turn our radicals or our square roots into decimals, but in geometry they really don't like that. Geometry is all about finding an exact answer, which means mastering square roots. So we're going to talk about square roots today and radicals, and to start off, let's just start by talking about what perfect squares are. Well, perfect squares are numbers that we get by multiplying something times itself. So 1 times itself is 1, 2 times itself is 4, 3 times itself is 9, 16, 25, and so on. There are infinitely many perfect squares, of course, because these are all just 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. That is perfect squares. And we're going to use those perfect squares in order to help us work backwards a little bit in order to find out what the exact answer is for certain radicals. In geometry, you're going to see a lot of square roots, a lot of radicals, and so we're going to need to be able to simplify them. So let's start there. Let's start with talking about how to simplify a radical. Here's an example here. We've got the square root of 20. We can break down into a perfect square and whatever other number we multiply by that perfect square to get 20. So we can start looking through our list here of perfect squares, and we want to find the biggest perfect square that goes into 20. So yes, 1 goes into 20, 4 goes into 20, and that's going to actually be the biggest perfect square that goes into 20. The square root of 20, we can rewrite this as the square root of 4 times, well, what number do we multiply by 4 in order to get 20? It's 5. So we can rewrite the square root of 20 as the square root of 4 times the square root of 5. And the reason we do this, and the reason we separate them like that, is because this right here is a perfect square, which means the square root of 4, that's asking us, well, what number do you square to get 4? It's 2. So the square root of 4 is 2. We can just bring down the rest of this, which is times square root of 5, and that right there is our radical in simplest form. Let's try another one. Let's look at the next problem. Now we've got the square root of 18. Let's look back up here at our list of perfect squares. Which of these perfect squares is the biggest perfect square that goes into 18? That is 9. So we can rewrite this as the square root of 9 times square root of, well, 9 times 2 gets us 18. So there we go. And then again, this square root of 9 is really just 3. So we bring down that square root of 2, and there's our answer. There is our simplified radical. Okay, pause the video now and see if you can try this next one, the square root of 75. All right, so I'm assuming you are all done now and you're pushing play to move on to see if you got the right answer. So let's see. What is the biggest perfect square that goes into square root of 75? That's got to be 25. So I'm going to rewrite this as a square root of 25 times square root of 3, because 25 times 3 is 75. And then now simplify by doing the square root of 25, which is equal to 5. Bring down that square root of 3. This is our simplified radical. Hopefully when you paused the video and did it yourself, you got the same answer. And if you did, very good. Good job. Okay, we're going to make it a smidge harder now by adding a coefficient to the front. This really doesn't change that much, so don't get too worried. We're just going to let the 3 hang out in front. Then we do the same thing that we've been doing with the radical that's left over. We need to find the biggest perfect square that goes into 32, and that's going to be 16. So we can rewrite this as square root of 16 times square root of 2, because 16 times 2 is 32. These are all being multiplied to each other. But now we can simplify it a little bit, because we know from the previous one that the square root of 16 is 4. So then we have 3 times 4 times the square root of 2. Now the additional step we have in this case where there's a coefficient is that now we have to do our 3 times 4 and make 12, square root of 2. Since those numbers are just plain numbers and neither of them are under a square root or a radical anymore, we can combine them by multiplying, and that's how we do it, because we want to have it in the simplest form. Okay, let's try another problem, another practice with this. So we've got 2 times the square root of 27. Again, we're going to leave the 2 alone on the outside. Square root of 27, what is the biggest perfect square that goes into 27? 9. 9 times 3 is 27. Square root of 9 is 3. And then we just combine these outside here. 2 times 3 is 6. 6 times the square root of 3. That's our final answer. So now, based on those two example problems that I just did, feel free to pause the video right here and try this next one, 5 square root of 24. Alright, now that you're back, let's go through it together and see if you got the right answer. So again, we're going to leave the 5 on the outside, and we need to think, what is the biggest perfect square that goes into 24? I believe the biggest one is going to be 4. 4 times 6 gets us 24. Now again, simplify the square root of 4 to get us 2. And multiply the 5 times 2 to get 10 square root of 6. Did you get that? If you got that right, feel free to leave a comment saying, oh, I got it, I did it, hooray. Why do we talk about radicals so much in geometry class? And I'll tell you why right now. Remember the Pythagorean Theorem? That's that thing to do with the sides of a right triangle, how the sum of the squares of the legs equals the square of the hypotenuse, or a squared plus b squared equals c squared. Well, say we're trying to find this c here, and they give us the 2 leg lengths. Okay, how we would usually figure this out is Pythagorean Theorem, which is a squared plus b squared equals c squared. We know a and b are 4 and 6, so we can just put 4 in for a, 6 in for b. And then let's just simplify a little bit. So 4 squared is 16, plus 6 squared, which is 36, equals c squared. Simplifying a little bit more, 16 plus 36 is 52, equals c squared. But the thing is, we don't care what c squared is, we want c. So we have to take a square root of both sides in order to cancel out with that squared and just get c by itself. But now we're left with c equaling the square root of 52. What number is the square root of 52? What is that even close to? It's hard to give a definitive answer of what does this even mean, or to understand or comprehend what this number is. And that's why we like to simplify them. So let's simplify it. Plus the geometry curriculums and Regents exam and final exam and the SAT and all the stuff like that really like to tell you to simplify these. Sometimes they don't even give you full credit if you don't. So how do we simplify this? Well, we need to find the biggest perfect square that goes into 52, and that would be 4. So this is 4, square root of 4, times the square root of 13. Square root of 4 is 2, square root of 13 stays like that. So this is your c value. And it's important to realize how to simplify the square roots, because they're going to always ask you for it in geometry class. Okay, we're going to look at one more thing here, which is the ultimate geometry trap. And that is squaring numbers that have radicals in them, like this. Okay, so let's just start with the first one. This is something that you will see a lot, and it's a lot easier than you think, because the squared power of 2 is the opposite, or the inverse, of a square root. So really, they cancel each other out. They say goodbye, and we're just left with 6. That's it. Easy. If you have a square root by itself squared, you'll just end up with the number inside. This last one is just a little bit trickier, because we have to square both things. We have to square the 2, and we have to square the square root of 5. Well, 2 squared, that's 4, and square root of 5 squared, well, from the previous one, we remember that the square root and the squared cancel each other out, so that would just leave us with 5, and then we're just left with 4 times 5, which is 20. And don't forget that when you have a number in front of the radical like this, that really means you're multiplying, so don't forget right here, you're going to be multiplying. Don't just leave the 4 and the 5 next to each other because you're not sure what to do. It's going to be multiplied together. Alright, well, hopefully this helped. This was a nice run through of simplifying radicals and looking out for where you're going to see radicals in your geometry class this coming school year. If you found this video helpful and enjoyed it, feel free to give me a like and subscribe to my channel to see more stuff like this. Comment any questions you have, as always, and feel free to check out all the other videos that I'm making, because there's a lot of things that carry over from one math class to another. And with that, I will say have a great rest of your day, and thanks for watching. Bye!